The world's tallest building, the Burj Khalifa, is built on loose sand, something that should be totally impossible. So what's the secret? Well, it's a massive concrete raft that was actually inspired by a desert flower.
So let's just think about this for a second. This wasn't just some run-of-the-mill engineering challenge. It was a seemingly impossible problem. How in the world do you stop 500,000 tons from sinking into sand? That's what the engineers were up against.
Okay, to really get a handle on just how massive this problem was, we first need to talk about what's under most big cities. And then you'll see why Dubai was such a unique nightmare for builders. All right, check this out. It's a tale of two cities, really. You've got New York, where something like the Empire State Building has it pretty easy. It's anchored right into solid bedrock just a little way down. But Dubai? Nope. The Burj Khalifa is just sitting on loose, sandy soil and weak rock. It's basically the difference between building on a solid slab of concrete versus trying to build on a pile of sugar. Just to put this into perspective, engineers drilled down 140 meters. That is almost the entire height of the Great Pyramid of Giza. And you know what? They still didn't hit any solid rock to build on. Can you believe that? All they found was more weak, crumbly sand and rock. The very ground they had to build on was fighting them every step of the way. So, what happens when you don't have a solid base? Well, you face this terrifying threat called differential settlement. And trust me, this is an engineer's absolute worst nightmare. It's when parts of the foundation sink at different speeds. If one side of the building sinks just a tiny bit more than the other, the whole thing can start to tilt, crack, and, potentially collapse. Okay, so you've got this impossible problem. Your foundation is literally sand. Where do you even begin to look for a solution? Well, interestingly enough, they didn't find the answer in some engineering textbook. They looked to the desert itself. They looked to nature. And believe it or not, the solution came from one of Dubai's most common flowers, the hymenocallis, or spider lily. It sounds kind of crazy, right? A 500,000-ton tower of steel and glass, getting its design from something so delicate you could crush it in your hand. But yep, this flower held the secret. And this is just a perfect example of something called biomimicry, basically copying nature's designs. The engineers literally copied the flower's tripod-like structure of petals to create the building's base. Just like the spider lily spreads its roots out for stability in loose soil, the foundation has this Y-shaped three-wing design to spread out that massive weight over a huge area. So they took this flower blueprint and turned it into what's called a high-performance RC raft. Now, the easiest way to think about this is to picture a snowshoe. If you walk in deep snow with just boots on, you're going to sink, right? But with a snowshoe, your weight is spread out and you stay on top. Well, this giant concrete raft is the exact same thing for the Burj Khalifa, but on sand. But wait, a raft on its own could still sink, even if it's a big one. The real magic, the critical part of this whole thing, is what's hidden underneath it. It's like an invisible forest made of concrete, and it's what's truly holding the tower in place. So here's the next big question. How do you create an anchor when there's nothing solid to anchor to? Well, you can't, so they had to create their own grip where there wasn't any. And they did this by driving a whole forest of concrete piles deep down into the ground. You see, the key wasn't hitting bedrock, because there wasn't any to hit. The whole game plan had to change. It became all about maximizing what engineers call skin friction. That's the force created by the friction between the entire surface of a concrete pile and all the soil and weak rock pressing against it. That friction is what fights against the building's downward push. Here's a great way to picture how this works. Imagine pushing a single stick into the sand. Pretty easy, right? Now try pushing a whole bundle of hundreds of sticks all at once. It's almost impossible. That's because the combined surface area creates so much more friction, and that collective friction, well, that's what's strong enough to support the entire tower. So now we have these two amazing pieces, the flower-shaped raft on top and this friction forest of piles underneath. But the really crucial part is that they don't just work separately. The true genius here is how they all come together to form one single, incredibly strong structure. It's all one integrated system. You've got the building's hexagonal core, which channels all the tower's weight straight down. Then, buttresses transfer that load from the core out to the three petals of the foundation. That raft then spreads the load evenly across all the piles, and finally, that friction forest of piles grips the earth, anchoring the whole shebang. It's an incredible, seamless system. And this entire setup, from the very tip of the deepest pile all the way up to the central core, turns the Burj Khalifa into what engineers call a stiffened rod. It means the foundation and the building are so tightly connected, they act as one single rigid element. This thing is so strong it can resist not only the ground trying to settle, but also the powerful winds from those famous Dubai sandstorms. And really, that's the amazing takeaway here. Stability isn't always about hitting rock bottom. Sometimes it's about spreading your roots, just like a flower does, to turn something weak, like shifting sand, into an absolute fortress. It kind of leaves you wondering, what other massive challenges could we solve just by looking at nature's time-tested blueprints? What other incredible secrets are just hiding in plain sight, waiting for us to find them?